Good morning, everyone. Hope you all are doing well. So this week, it's gonna be about deployment. Today, we're just gonna do a small introduction on why we need it and what's the importance behind deployment. And we'll also take a look at how to create a build version of your app that you created. And we'll take a look into why the build version matters and what it essentially does. So I will wait for a couple more minutes to see if more people join and then begin. But in the meantime, if you do have any questions or comments, you can let me know. Okay, I guess we can slowly begin. Let me just get the slides. Okay. I believe everyone can see my screen. Okay, so deployment. What do we know about it so far? I believe we talked about it a lot, and we've also done probably not the more industrial version of it, but we did deploy our projects, right? Before. But yeah, so far from what we've seen and what we've learned, what can you guys tell me about deployment? Making it live. Yes, correct. So essentially, when you deploy it, you are making it available for the client or the end users. So that's the main purpose, but there's a difference between two versions of the application. One is the dev version and one is the production version. When we deploy it, we deploy the production version, not the dev version. We'll take a look at that later on, but now let's go into our lecture. So the first thing I want to talk about is the software development lifecycle. So we've all seen this from time to time throughout the whole course. We start off with analysis, then UI UX design, implementation, testing, deployment, and maintenance. So right now we are in the deployment stage. And this is one of the most important stages of software development. Each and every single one of this is very important, but deployment is what essentially takes your product to the end users. So that being said, what is deployment? Deployment in software development refers to the movement of a developed application from a testing or development environment to a live production environment. It involves tasks like configuring servers, installing software, and thorough testing to ensure the software works as intended. The aim is to make the software accessible to end users in the target environment with minimal disruptions. Deployment strategies such as blue-green deployment, canary deployment, and practices like continuous integration, continuous deployment are often used to facilitate a smooth and efficient release process. So this is essentially everything I said in a more bookish way, but we will take a look at different deployment strategies in the later part of the slides. But deployment itself is essentially just making sure you're moving your application from a testing or development environment to a live production environment, which will be available for the end users. Now, why is it important? Deployment in software development is crucial for delivering applications to users promptly, ensure a shorter time to market, addressing bugs and security issues, and adapting to changing requirements. It enhances user satisfaction, operational efficiency, and supports continuous improvement. Efficient deployment processes streamline the transition from development to production, making software updates and new features available with minimal disruptions. You'll see later on for different development processes or different deployment processes actually. So for in those cases, they have different ways to kind of go about a certain task. One of the biggest tasks is usually the continuous deployment. Because when you for any kind of application, you'll see new versions come out every now and then. And we as programmers, as developers, we have to make sure that those updates are being pushed into the main project, or those updates are available for the end users without disrupting their experience. For example, you're using an application and all of a sudden you see that everything's down, the server's down, the app's not working. It just says that app is down due to maintenance issues. That gets pretty annoying at one point, right? So this is very important to make sure that the end users still are able to use our application, regardless if we're just letting it be, as letting the product stay as it is, or we are making continuous updates. The end user should always be able to use the product. So, types of deployment. So the first one we have is blue-green deployment, canary deployment, rolling deployment, and A/B testing. If we move into what they actually look like, the first is blue-green deployment. Now, blue-green deployment is a deployment strategy in which you create two separate but identical environments. One environment, being blue, is running the current application version, and one environment, which is green, is running the new application version. Using a blue-green deployment strategy increases application availability and reduces deployment risk by simplifying the rollback process if a deployment fails. Once testing has been completed on the green environment, live application traffic is directed to the green environment and the blue environment is deprecated. this is exactly what I was saying. We need to make sure that the end users still get to use the application without affecting their user experience. So in that case, blue-green deployment can be really helpful since we are running the current application in one environment and the newer application version in another environment. The advantage of this being we can just redirect the traffic to the green environment, which is the new application version when it's ready. Or if there's a fail in the green environment, we can just redirect the traffic back to the old one, which is the blue environment. Does that make sense? All right. So let's take a look at some advantages and disadvantages for this. So some pros would be no downtime deployment. What does that mean? So with blue-green deployment, whenever there is a critical bug found on the production server, traffic is redirected to other environments. This leads to no downtime for the end users. This is one of the biggest advantage for this. Standby. Whenever there is a system failure, we can immediately perform rollback and recover safely without disturbing the end user. With blue-green deployment, once we switch to the new version of the application, the older version of the application is still available as a backup. Therefore, in case of recovery, we can easily swap the environment and redirect the traffic back to the old version. Blue-green has proven to be impactful in reducing risk in the application development process. So, yeah, I mean, for blue-green, the main objective is so that you have a safe, like a fallback plan for your application. So in case the new version has a bug that's causing major issues, without user experience being altered, we can just roll back to the previous version and make sure the user still gets to do whatever they would need to do from our website. So immediate rollback. In some cases where the new feature is not working properly, we can switch to the older feature application by performing rollback, as we talked about. Testing in production environment. There are scenarios where deploying a new set of code works fine on local, but when deployed in the larger infrastructure, it becomes problematic. By using blue-green deployment, we can check the performance of the code on the production server without disturbing the users. So that's also something very important because remember when we were talking about catching bugs and everything during the testing lectures, it's very important that we make sure when we're testing, the users don't get affected by that. So when you're testing, very likely some errors do come up, some bugs appear, but the thing is, if we have a separate environment for it, the users are in a separate place and the testing is happening in a separate place, that makes it completely detached from the users. And once the testing phase is passed, then only we redirect the traffic to the final version. Some disadvantages would be database sync up. So schema changes are complex to decouple. In the case of blue-green deployment, syncing of database and data changes should be synchronized between the blue and green environment. In case of relational database, it can lead to discrepancies. So since it's in two separate environments, the synchronizing of the databases and data changes might actually be a little problematic. They might conflict each other. So that's a pretty big problem. Next, we have in some scenarios with large infra, it is possible that sometimes QA test cases will not detect errors or bugs in a non-live environment. So that's also important. So in general, what's happening is when we are testing from our end, some things do get missed. Some bugs probably don't appear because when you are using your product on a broader scale, then only the really small bugs come up. So for that, this might be an issue because if it's not on a live environment, some bugs might not appear. Then we have dashboard required. Since we have two identical production environments with a different version of the code, while running the deployment, it becomes important to monitor insights with packages and code at any point of time to trigger things. So observing the two deployments in two different environments is very important so that if we need to change something, we can change it immediately without the user experience being hampered. So lastly, we have costs. So for blue-green deployment, we have two sets of environments running in parallel time. Thus, it increases the cost of production. Maintaining two production environments can get costly in the long run. So that's all about blue-green deployment. The next one that we have is canary deployment. Canary deployment essentially is a software release strategy that involves gradually rolling out a new version of an application or service to a small subset of users or servers before making it available to the entire user base. The term canary is derived from the practice of using canaries in coal mines to detect toxic gases. Similarly, canary deployments act as an early warning system for potential issues in a new release. So over here, what we're doing is we're rolling out a new version to a small subset of users before making it available to the entire user base. So this sort of acts as a live testing strategy also, you could say. So for the small set of users, if any problem appears, we can immediately fix those. And when we actually make it available for the entire user base, those issues or bugs are not there anymore. So the user experience is going to be smoother. Now, if we talk about the advantages, the first one would be service evaluation. So over here, you can evaluate multiple service versions side by side using canary deployments in real-world environments with actual users and use cases. So in this case, you're not testing it by yourself. You're having users test it for you. Not really testing, they are using it, but you can call this a sort of test because you are not actually making it available for everyone, just few users who will definitely use your application, and in case if they run into any issues, you will definitely know about it and you can work on it and fix it. It's cost effective because two production environments are not required. It is less expensive than a blue-green deployment. Testing, canary deployment can be used for A/B testing as well. We will take a look at A/B testing later on, as it offers two alternatives to the users and selects one with better reception. Inbuilt capacity test. Normally, it is difficult to test the capacity of a large production environment Canary deployments offer inbuilt capacity tests. Since they are in a smaller scale, those kind of features are available. Then we have feedback. With the release being made for targeted or a sample number of users, you receive invaluable feedback or input from real users and modify Canary versions for improvements. So it's not only actually for finding out issues or bugs. Sometimes when you deploy to a certain set of people, you get comments or you get opinions about it as well. And based on those, you can make sure that you adjust your project or you adjust your product to give the users something that would be more like what they want. So it's like when you are sampling a large set of, say, products. So when you, what would be a good example for this? Okay, so say for clothes, right? When a factory creates clothes and sends them off to the company, there are thousands of pieces, right? They don't really test each and every one of them. They test like a sample set, maybe 10, 20, and based on that, they decide if the whole batch is good or not, or if there needs any kind of changes. It's very similar to that idea where we are sampling a small set of users and we're taking their input and making it into something that probably will be relevant to the rest of the users as well. Next, we have no cold starts. Unlike new systems that take a while to start, Canary deployments build up momentum to prevent slowness of cold starts. Since you are deploying it to a smaller set of people, it's much faster as well. It says zero downtime. Just like blue-green deployments, a Canary deployment does not cause downtime because, again, well, the difference between the two would be for blue-green, you had two separate environments, you had a fallback, but in this case, you don't have a fallback, but you're not really making it available to everyone either. Just a small set of people, so the user experience is not being affected that much. And obviously here as well, you can roll back to previous versions. But yeah, that's all for the advantages of Canary deployment. Now let's look at some disadvantages. Script testing. Canary release scripting is challenging since human verification and testing can take a significant amount of time. The monitoring and instrumentation that is required for production testing may call for further research. So it's time consuming because we are getting real-time feedback from users. It might take time to actually come up with a more sound decision on if the product is actually all set for your final deployment. Complexity. Canary deployments share the same complexities as blue-green deployments. Like many production machines, user migrations and system monitoring. So there are a few complexities for this kind of deployment, as mentioned over here. User migration, system monitoring, all these things can take time and require continuous monitoring to make sure that everything is going as planned. Time, yeah, as we talked about, it takes a bit of time to make sure that you get your final product or your final product is as per user taste or how the users like it. Then deployment at an enterprise scale. An enterprise canary deployment is difficult to accomplish in an environment where the software is loaded on personal devices. Setting up auto update environment for end users may be one method to get around this. So on an enterprise level, manually loading software into personal devices or making it available for certain people might be very tiring. Because when you are continuously updating it, you would have to update it manually if that's how you're loading the software into the devices. But yeah, as said over here, an auto update environment for end users may be one method to get around this. So these were the first two kinds of deployment. Any questions so far? Anyone? Any questions? Okay, so as you no more questions. So let's move forward and go for rolling deployment. So what is rolling deployment? It's a type of deployment where so it's essentially a software release strategy that staggers deployment across multiple phases, which usually includes one or more servers performing functions within a server cluster. Rather than updating all servers or tiers simultaneously, the organization installs the updated software package on one server or a subset of servers at a time. The rolling deployment helps reduce application downtime and prevent unforeseen consequences or errors in the software updates. So in this kind of deployment, we are deploying across multiple phases, or we are deploying in one or more servers within a server cluster. So rather than updating all the servers simultaneously, you have to install the updated software package on one or a few servers at a time. So again, this does help with application downtime, and it will prevent unforeseen consequences, because once you do that, you'll see if there's any issues with the updates. Some advantages could be continuous availability. Rolling deployments ensure continuous availability of the application as updates are incrementally applied to subsets of servers or instances. This minimizes downtime and keeps the application accessible to users. So for rolling deployment, it's continuously available for the users. Updates over here are pushed into the servers incrementally, so it really minimizes the downtime and keeps the application accessible to users. Gradual rollout. Updates are gradually rolled out to a subset of servers at a time. This controlled and systematic rollout reduces potential impact of issues, allowing for a smoother transition between versions. So instead of updating everything in all the servers at once, we do it one at a time, or maybe a few at a time. This makes sure that the updates are more controlled Controlled in a sense, you are actually closely monitoring what's happening over here. And if you do come up with any issues with any of the updates for the servers, you can work on that for the rest of the servers, making the user experience and the transition between two versions much more smooth. Next, we have smaller resource requirements. Again, they compare it to blue-green deployment. So rolling deployments typically require fewer resources compared to parallel deployment strategies like blue-green deployment. So this is advantageous, particularly for organizations with resource constraints. So this does not require two separate work environments, just one is good enough, which makes it less costly as well. Continuous continuous monitoring. Rolling deployments enable continuous monitoring of the application's performance and health throughout the update process and facilitates the early detection and resolution of issues. Like we talked about, since we are updating it slowly, one at a time, if any of the servers come up with an issue, we can look into it and make sure that doesn't happen for the rest of the servers. Now, if we take a look at a few disadvantages, extended deployment duration. Now, rolling deployments may take longer to complete, especially for large-scale applications such as, what could be a good example? Say e-commerce websites, usually they're pretty large in scale. So for operations like those, it might take long to actually make sure everything is available for the end users. So let's take a look at this again. So it may take longer to complete, especially for large-scale applications, as updates are applied gradually. This extended duration might be a concern for organizations aiming for rapid releases. For a lot of e-commerce websites, you'll see they kind of start with a minimum viable product and then slowly starts making updates into their website. And those rapid updates usually take a long time to make sure the entire website or your entire project plan is actually complete. So complexity with database changes, coordinating significant database schema changes or data migrations during a rolling deployment can be complex and requires careful planning to ensure consistency. Since we are uploading it to multiple servers, data schema changes or data migrations could be a little more complex than the other ones. Potential for inconsistency. Instances of the application may be running different versions simultaneously during the deployment. Ensuring consistency and compatibility between these versions can be challenging. It's similar to the other one as well, the last one, canary deployment. So, but the difference is over here, you'll be running in different servers and kind of going through all the different servers with your new code takes time. So there is a chance that it might be inconsistent for a bit while you're making those updates. Limited rollback scope. So while rolling back is easier than in some other deployment strategies, the rollback scope is limited to a subset of instances that have already been updated. This limitation may impact the ability to quickly revert to the entire system. Okay, so for this, it does give you the option of rolling back to previous version, but since we are not really updating everything at once, we are doing it one at a time. So all of them might not have been already been updated, and that takes the rollback much longer than the other ones. Dependency challenges. Managing a rolling deployment with dependencies across different components or services can be challenging. Compatibility between the rolling updates and these dependencies must be carefully maintained. So there might also be inconsistency across dependencies as well. Because if something changes in one part of the code, you have to change it throughout every single server. So maintaining that kind of consistency is also very important. That finishes up rolling deployment. Any questions, anyone? Am I audible? I will take that as a yes. Okay. All right. So if you guys don't have any more questions for rolling deployment, we can move forward to A/B testing. So A/B testing, also known as split testing or bucket testing, is a methodology for comparing two versions of a web page or app against each other to determine which one performs better. A/B testing is essentially an experiment where two or more variants of a page are shown to users at random, and statistical analysis is used to determine which variation performs better for a given conversion goal. So this is a little different in a sense. We are making it available for a subset of users, but what's happening is we are not giving everyone the same kind of application. So everyone gets a different style of application, a different variation of the application. And based on the feedback, the statistical analysis, we decide on the final product based on which variation did the best among users. Let's take a look at some advantages. So some advantages could be get clear evidence. It's easy to see how many users complete a transaction with site A over site B. The evidence is based on real behavior, so it is hard data of the type that money men love and can be presented in a simple looking, hard-hitting chart. So, okay, what this essentially it gives you clear evidence of what's happening. So over here, when you're pitching your product to a business and say you are divided among two different kinds of ideas on how to go about this project or how to create a functionality, this kind of testing will definitely give you a hard data on how the users react with two different sites, or which one's more efficient, which one's more faster. Everyone likes seeing hard data because it's easier to understand without going into technicalities. So test new ideas. If you have an innovative idea for an existing site, A/B testing provides hard proof as to whether it works or not. However, you will need to implement the big idea in hard code before you can test it this way. So like I said, if you are divided between two different ideas, you can definitely create two different versions and test it among users to make sure that the required final product is actually making sense for the user, not just the developers. Optimize one step at a time. If you run a large site or many sites, then A/B testing is a fantastic opportunity to patch test by starting out in a small corner and then working up to the main pages of the site. However, can smaller site users less? So, in other words, to summarize all this, it's easier to say that when you are testing two different kinds of product, it's easier for you to test them as well. So this kind of testing allows you to start testing from a small part of the code and go to a bigger part. So the last part would be answering specific design questions. For example, the color of a button or maybe a layout, how many input forms should there be in a particular section? All these questions can be answered with A/B testing, where two different sets of products are being used by two different sets of users. That gives you a more detailed answer on whether which version of the application will be working better in the market as a final product. So the disadvantages could be it takes a lot of time and resources. Since you are testing between different sets of users, it will take time to get feedback and analyze all that. So this only works on specific goals. This kind of testing is ideal if you want to solve dilemma on which product page gives you the best results, but it's very specific to its goals. So yeah, lastly, we have, this could end up with constant testing. So for testing like this, you may have to test this again and again based on what kind of data you get. So once the test is over, that's essentially it. The data is useless for anything else. So if you have new ideas, that data won't probably be as helpful to those ideas. I think that's about it for the testing slides. Any questions, anyone? Anyone with any questions? This was more of an introductory slide on the kinds of deployment and why we need it, how we need it. These are important to know for later on because these kind of ideas are stuff that you will probably implement when you are deploying a final product for a company or even your own company. So these strategies really help. Any questions? Any comments? No comments? Okay. So I will stop sharing this and let me open up VS Code. So I want to show you guys how to create a build version for your app. I think we've seen it before, but we really should see what's actually inside it. Okay. I believe VS Code is visible for everyone. Okay. So that's all good. We have our Notes app over here. This right here is the development build, but we need to create a production build. Why do we need a production build? Is so that everything is in a more compressed, what's the best way to say it? Everything's in a more compressed manner, in a way that it doesn't take up as much space as a development version app requires. So when your app is in development mode, you get a lot of different options that you won't probably get in the production build. So those extra options actually take up more space, which is not necessary. And also when you go to the build version, everything gets hashed out and mapped into different folders. Well, so let's take a look at that. Let's first see how to create our build version over here. It's very simple, just one line, npm run build. Okay, so it's creating an optimized production build, and it's right over here. So, okay, let's see what we have inside. We have 4 files and 1 folder. If we go into static, we have our CSS. See, everything becomes more compact, takes up less space. So they just format it on their own based on how they need it. So this is our main.js. This as well gets compressed and hashed out. Everything is getting mapped as well. So whatever is happening in the background. We don't have to worry about how they're doing it. But yeah, everything that we had is kind of getting mapped into these files over here. Media, I don't think we had any media. Oh, the medias are still there. Okay, so that's not a problem. What else do we have? Okay. Then we have the manifest.json. It's for the images, I believe. And this is our index.html. So in other words, every single component or every single file gets compressed to the point where it's actually kind of impossible to understand what's going on if you look at the code from here. Because it's all mapped and hashed out. It's not the regular version of the code that we usually see. See? It's all mapped out over here. But yeah, so the question would be that why or what actually happens? So the first thing would be in modern JavaScript code, it often uses features that might not be supported in browsers. So what they do, they sometimes convert those codes into an older version and make it compatible for a wide range of browsers as well. Then in larger projects, there might be numerous JavaScript or CSS files. What just happened to my computer? Sorry, something happened. My computer just glitched. Okay. What was I saying? Right. In large projects, there might be numerous JavaScript or CSS or even other files. Now, bundling tools like Webpack are often used to combine these files into a smaller number of optimized files. But in this case, we didn't really have a lot going on. It's just the JavaScript ones that kind of got compressed on their own over here and mapped. So not a lot to worry about there, but the whole idea is to make sure that any kind of unnecessary code or any kind of unnecessary parts of your project is not available for the production build. Because when you upload it to the server, in most cases, those extra bits of code or extra files or extra whatever it is inside your project directory might take up unnecessary space in your hosting. So it's important to have the production build ready and in your hosting or where you want to run your website. But yeah, essentially that's about it for deployment, at least for the introductory part. We will see more of it later on. We will be looking at the CI/CD pipeline. We will look at a proper full stack deployment. And good news, you guys are going to have an assignment on Friday on deployment as well. But it's going to be very small. That's for sure. The deployment assignment won't be that big. But that is the plan for this week in the coming 3 days. 3 days, right? Yeah. But yeah, that's about it. Do you guys have any questions so far about what we've learned today? Anyone? Any questions? Okay. Guess I'll take the silence as a no. But yeah, that's about it for the introductory lecture. We can finish it off over here, go on a 10-minute break. I'll come back and open up the breakout rooms, and if you have questions, we can help you out over there. So yeah, see you guys in 10 minutes.